Hello, and welcome to Yang Backward Compatibility webinar. My name is Nabil Mishraf. I'm a solutions architect in the automation team at Cisco. In this presentation, I will be covering the definition of backward compatibility when it comes to Yang update rules as described by the RFCs, interoperability issues with managers such as service orchestrators, network management systems, and tooling that will help you debug or test Yang implementations on a device. So let's start with backward compatibility definition. As defined in the Network Programmability with Yang book, the definition is comprised of two codes that I took from the book. This is the first code. All configurations valid in an earlier version of a module must remain valid in all newer versions of a module. This means if you're upgrading Yang modules on the device, the Yang specification and the data that was used by a manager or an orchestrator can still work with the new Yang module, meaning that the data itself, all the configuration data that's stored under one specification, earlier specification, is still valid per the new specification, although it might be missing some of the configuration that is should not be needed by the new specification, but should be optional. So if there is anything missing, that should be considered optional in the Yang schema itself. So let's go to the second quote here that completes the definition of backward compatibility. The meaning of every valid configuration value must remain the same across the versions. What this means is that the existing configuration that you have or you had on the device, as well as on the orchestrator side, still means the same thing in terms of the implementation on the device. So that meaning is something that's not possible to describe in Yang itself, but it is something that needs to be respected if you want your new Yang specifications to be backward compatible. This solves a lot of issues that may arise if you're changing the meaning of the data on the device while the orchestrator is still using that data with a different meaning, basically, different intent. Now we talk about intent in this case. So the intent should not have different interpretations, one interpretation by the orchestrator and a different one by the device. So this defines a backward compatible Yang specification. So let's give some examples here. These are very simple, basic examples just to illustrate what we're talking about when it comes to non-backward compatible change. On the left side, we have an old Yang module that has a type definition on top and a leaf log facility in the bottom with the default value of local 7 and also the type. This is the same type used here. And we have an existing configuration of log facility with the value mail, which is another enumeration in this type. The new Yang model that we introduced, we wanted to get rid of the mail enumeration. So we removed mail enumeration from this type. We still have the same node, same leaf definition here, same type, also the same defaults. So by removing mail from here, that means log facility can never have the mail as a value. So the existence of this configuration and this new Yang module is conflicted. So there is a conflict here. This means we cannot keep this configuration on the device Otherwise, this is not valid. So the second case is about, or second example is about backward compatible change. It's the same Yang model, also the same configuration, but in this case, instead of removing something from the enumeration, we added a new enumeration, which is local 8 here. So we kept mail. This case is obviously backward compatible since mail, the existing configuration, is still valid per the new specification. So there are some cases where or when we can break backward compatibility, or we need to break backward compatibility. And these cases can be described in the following 2 points. When a node in Yang was never used or was experimental. In some cases, we might introduce an experimental node in Yang that we're testing with to see it's not going to be the final node of the Yang module, but in this case, it is required for the users or consumers of that Yang model to know about this experimental feature. When there is knowledge, common knowledge between the consumers and the providers of the Yang specification, we can avoid, it is fine if we break backward compatibility because it is meant to be broken anyway from the get-go. The second case is if a vendor has full control over both client and server side of the Yang interface. Obviously, this is not leveraging the strength of Yang being a standard because the vendor can do whatever works for their and as their service orchestrator or their manager and their devices. So they have full control. They can do with backward incompatible changes, and the Yang models or the Yang specification of the devices or the network elements is never meant to be exposed to third party, whether it's a customer or a vendor. So it's never meant to be consumed or used directly by someone else. So these are really the only cases where we can break backward compatibility. If backward compatibility is broken outside of these two scenarios, then we can expect we'll have big problems with once deployed in customer networks. So new features. So this is one of the topics that can result in breaking backward compatibility wrongfully. So it's not part of any of the cases before, but in this at this level here, we're talking about Yang modules that are published to a third party or to the customer, basically to a third party for integration with other tools. So new cool feature will result that results in a non-backward compatible change. Let me describe how. When adding a new feature that doesn't follow the update rules to maintain backward compatibility, as mentioned in the RFCs, and we'll talk about them in a little bit. In that case, we are breaking backward compatibility. We are adding nodes, for example, in Yang that are mandatory, that didn't exist in the previous specification. We're not accepting, for example, empty data for those nodes that we added. And there is another presentation about blank Yang configuration. So in that case, we are breaking backward compatibility. The proper way when adding a new feature is to use a new module with a different namespace. This may introduce the problem of aliasing if not properly used by clients. So there is an aliasing video that you can look at to understand the aliasing problem. and how to solve it. It tells clients they need to understand the new module in order to use the newly added feature, and it can be expensive. Why? Because we added something that's non-backward compatible, which means that for it to be consumed by the customer or third-party tools, the third-party tools need to adapt and quickly. This can be expensive for the teams doing the development on the manager side. So the proper way in this case is to use a new module that can be excluded from the manager if it's not implemented yet. So while the manager is working on implementing the new module, the existing data can remain valid per the new specification. So this is the reason why you can separate the feature in a new module, because it's easy to exclude a module from the list of modules used by a manager. Now let's talk about Yang updates. Quoting RFC 7950, changes to published modules are not allowed if they have any potential to cause interoperability problems between a client using an original specification and the server using an updated specification. So in this definition, we're talking about almost the same thing that we mentioned earlier, but we're introducing here published versus unpublished Yang modules. This is a naming that you need to be comfortable with, and you need to know the risks of publishing Yang modules, mainly publishing when it comes to publishing Yang modules to be used by customers. So published means Yang models are published by a vendor to be used by customers. Unpublished, they are not published to customers and they are used internally only. In some implementations, device side or network element side, you may find several Yang modules that are used internally only, or are used by specific interfaces such as CLI, such as SNMP, and are never meant to be used with a programmable interface, such as Netconf, RESTConf, GNMI. So published Yang models obviously have stricter update rules so that you can preserve backward compatibility. So what are the rules, these update rules that we keep mentioning? These rules can be found in RFC 6020 and also in RFC 7950, specifically in the section 11, updating a module. Most Yang updates are relatively small, so you'll have and something that's experienced daily is when updating Yang modules, you may introduce or change something so small that you think it's not going to affect backward compatibility. An example of that are type changes. So it's very simple to break backward compatibility by changing the type of leaf. A simple example of that, and an obvious one, is when changing a type from a string to an integer. Anything other than integers that is present in the previous specification is going to be invalid per the new specification. Data representation changes also is another very small change that can cause backward incompatibility. So this refers to how data is represented on the device versus how data is configured from a northbound manager. If the data is changed, the representation of the data is changed once set by a manager. When the manager reads that data, it's going to find a different value. So that will cause the manager to think there is an out of sync change. There is an out of sync situation, or there is some other manager managing this network elements and making changes to data that shouldn't be changed. So that is a big problem for third-party tools. range changes also. Per the update rules, it is required that any changes to ranges or pattern change that is next here, or when statements and must statements, anything that restricts the data. If you are making the change in a way that restricts even more the data that can be accepted or that is considered valid, in that case, that breaks backward compatibility, because you're going to have data, you might have data on the manager side that is outside of the new range or the new pattern. So this is an obvious, also another, it can be caused by a very simple change by the Yang implementers. So we talked about the restriction part, and this restricting anything, even types or semantic constraints like must, when, min element, min occurs and max occurs, will cause a backward compatibility issue. So the rule is that these, when changing these Yang statements, you can be sure it is backward compatible if you expand them, you enlarge, for example, the range, or the must statement, you're accepting more conditions. In that case, you are backward compatible. So how does that affect interoperability? So we talked about all these issues. We also mentioned some cases for when this breaks interoperability with managers. But this slide just lists this in clear text. Even when backward compatibility is respected, some behaviors like the following can break automation. So this is something that we didn't talk about in the previous slides. Adding nodes in Yang for the same configuration. This is one case that can break automation. This is another level. We're not talking about breaking backward compatibility. In this case, we are backward compatible, but there are scenarios within this backward compatible changes that can break automation or break interoperability with automation tools. Adding nodes in Yang for the same configuration. In order to maintain backward compatibility, some implementation opt for adding new Yang configuration nodes with new names, types, and all, but controlling the same functionality as the original nodes. So this will result in an aliasing issue, and we have a video for that I recommend watching. This can work well if clear instructions are given to the clients to use one or the other definition, but not both. Undefined behavior may result from setting the original leaf to one value and the new leaf to an incompatible value. So please visit the aliasing video. It will have more details on this. There is no guarantee that existing clients may not hit any issues with a Yang change, even when backward compatibility rules are followed. So there is no an example of that is adding a new enum enumeration value. Well-programmed clients should ignore leaves returned by a server if they have no knowledge of them. This is rarely implemented in the field, but this is very crucial because a device can be adding new leaves, new elements, and the server can have, or rather the manager or the client can still be working on the using the previous specification. So when talking to the device, when doing get command, for example, via a netconf, and the device returns these extra leaves that are not known by the client, they should be ignored in that case. Okay, tools. Let's talk about what tools you have in hand in order to test. We have the Payang tool. It is an open source Python-based tool. It is possible to check for non-backward compatible issues using the tool. Payang can compare two modules and detect some non-backward compatible changes. There is an option for that. Payang cannot detect all non-backward compatible changes related to some semantic changes. So there might be some things that it cannot detect. So it's best to rely on other tools to do that. NIAT, which stands for Automation Testing for NetConf and Yang. This is a set of tools that helps NetConf and Yang implementers to test their implementation, to test for transaction issues, and can catch some but not all backward compatibility issues. So it is very recommended that when changing Yang modules, there is a review process where multiple people can take a look at the Yang modules and make sure that there is no non-backward compatible compatibility issue. NIAT can help, as I said, Payang can help as well, but they're not going to cover all the cases. Okay, resources. You have access to NSO via this link. Of course, the RFCs regarding Yang 7950 and 6020 that talk about the update rules in order to maintain backward compatibility. There is also RFC 8407, which is a guideline for authors and reviewers of documents containing Yang data models. This is very useful document that talks not only about backward compatibility, but other aspects of the Yang language. And of course, the book Network Programmability with Yang, which is it talks about the structure of network automation with Yang, NetConf, RESTConf, and GNMI, and has several interesting topics that are relevant to backward compatibility. With that, thank you for attending this presentation. And don't forget to watch the rest of the webinars in this series of advanced automation principles.